There are several ways to simulate data in an outstation using DTM. In this video, we'll show some of these methods, including changing data manually, automatically changing data using comma-separated values or CSV files, using JavaScript, and using flowcharts. To change data manually, we first need to show a point list. I'm going to show the point list for the entire outstation folder. So to do that, I right-click, select Show Point List. To change a point's value, I can click on a point in the point list. For binary inputs, I can then select the desired value from the drop-down box. Let's change the breaker to be on. For analog values, I can type in the new value. Let's set the new value to 250. This will change the value in the outstations database, which will be reported on the next pull from the master. The master will then update the insight display. We can also look in the master's point list. To do that, I'll right-click on the folder, select Show Point List, and here we see the points reported in the master's database. Automatic changes are useful for creating large amounts of data changes. With automatic data changes, DTM will toggle the binary inputs and change the analog inputs. To configure automatic data changes, we can right-click on a device or a folder. I'm going to select the folder, which will allow data changes to be applied to each outstation. Once I right-click on the folder, I can select Simulate, Configure Automatic Data Changes. This will open a configuration dialog, and in that dialog we can select which outstation should apply the automatic changes. I'm going to select the top checkbox, which automatically selects each outstation. Next, we need to set the change period. We can set a period for each device, but I'm going to set the period here in this top box, which applies to each selected device. I'm going to stay with the default of 5 seconds. When I click OK, the changes will begin. Here we see changes being applied to the outstations database every 5 seconds. Those changes are sent to the master. Looking at the master's point list, we can see the updates. The insight display is also updated by the master, as we can see here. We can also use comma-separated value or CSV files to simulate data. Here is a sample CSV file. This CSV file was created by editing the 61850 CSV file that we used in the 2015 Distributech demo. You can also use the Communication Protocol Test Harness to capture states and create CSV files. In the CSV file, each row represents a point. The first column describes the path of the point, and subsequent columns represent a state. In this example, I have 3 normal states with different values of current, and 1 fail state. I have separate CSV file for each breaker being simulated. To apply the CSV file, we first need to load it. To do that, we right-click on a session in the outstation and select Simulate, Load CSV File. This will open a browser. We can import CSV file and choose the appropriate file. I'm going to load a CSV file for each simulated device. Once a CSV file is loaded, we can apply the various columns from the file. To do that, we right-click on the CSV file, select Apply Column, and then select the desired column. The slaves database is updated accordingly, and the resulting change will be sent to the master, which will update the insight display. We can also apply columns to multiple devices at once. To do that, we right-click on the folder, select Simulate, Apply CSV File Columns. In the pop-up dialog, we can drag the column header to the top bar in order to sort by columns. We can then expand the column and select the desired devices. We can use multi-select, click and shift-click or control-click to select multiple devices. I'll select all of the devices using shift-click and apply them by clicking OK. Once again, we can see that all of these changes have been applied to the outstations databases and reported to the masters, which have updated their database and updated the insight display. We can also configure DTM to play back the data in CSV files. To do that, I right-click on the folder and select Simulate, Configure CSV File Playback. I want to select all of the devices, and I'll set a period of 2 seconds. I also want to check the Restart Playback on End of File box. This will create a continuous loop, going back to apply column 1 again after all of the columns have been applied. When I click OK, DTM will apply all of the points in the first column of each CSV file for each device. After 2 seconds, it will apply the second column. After 2 more seconds, it will apply the third column, and so forth. 2 seconds after the fourth column has been applied, the first column will be applied again, and the process will continue to repeat. Looking at the outstations point map, we can see the data value changes. We can also see those changes in the master's point list as the master updates its database as it receives data from the outstations from each pole. The master also updates the insight display. Viewing the insight display gives us a visual representation of these changes. Although not shown in this video, you can also manage CSV files from JavaScript and flowcharts. Using JavaScript to simulate data is very powerful. It's limited only by your imagination, and perhaps your ability to code in JavaScript. In this demo, we'll create a short JavaScript program to simulate a sine wave. First, we open the JavaScript editor by clicking the JavaScript editor icon. Then we drag the point we wish to simulate into the JavaScript editor. This creates an insight tag that associates a variable name to the path of the point. Let's simplify the variable name and just call it P0. Now we just need to write the JavaScript. We'll use a for loop to cycle through 360 degrees, stepping 10 degrees at a time. We can use standard JavaScript libraries, so here we'll use the math.sine function to create the sine wave. Note that math.sine uses radians instead of degrees, so we'll have to convert I from degrees to radians. We'll do that by multiplying by pi. We'll use the math.pi function and divide by 180. Finally, let's pause for a second between each update. Now let's check for errors. To do that, we build the script. Since it built cleanly, we can run it. Just click the Run icon and watch the output vary from 0 up to 1, back through 0 to -1, and back to 0 as it cycles through the sine wave. We can also use flowcharts to simulate data. Here I have a flowchart that creates 10 random values. It initializes a counter, sets a new tag value based on a random number between 0 and 150, delays for a second, increments the counter, and if the counter has not yet reached a value of 10, loops back to set a new tag value. When we set the tag value, we need to specify a path. We can get that path simply by dragging a point from the point list onto the setTagValue operator. I can run the flowchart in debug mode to verify that it works. In debug mode, execution is slowed and each element of the flowchart is highlighted as it executes. It looks like it ran okay, so now I'll uncheck debug and run it again. This time we'll see that the value changes once a second. As you can see, it's very easy to set up flowcharts. Your ability to simulate data using flowcharts is limited only by your imagination, and you don't even have to write a line of code. So we've seen multiple ways to simulate data in DTM. We can simulate data changes on individual points, we can simulate large amounts of data using automatic data changes, and we can simulate real-world states by applying CSV files. Automatic data changes in CSV files can be applied to individual devices or to multiple devices simultaneously. We can also create changes via JavaScript and flowcharts.